Now, here, a testing on bushing can be carried out by means of different tests. These tests are as follow. We are having the first one, power factor test, partial discharge test, wet power frequency voltage withstance test, momentary power frequency voltage withstance test, visible discharge test, and last one is the impulse test. In a short, I will give the introduction of all these tests. Here, the power factor test and tan delta test is very important on a bushings. Because of the power factor test and tan delta test, we are able to determine the insulation strength of a particular insulation material. So this is the power factor test which can be conducted by using the shearing bridge. Okay. So tan delta test and power factor test we can conduct it by using the shearing bridge also. Second one, a partial discharge test. How the partial discharge test should be conducted? And simple, in between two conducting part, we are placing a bushing and we are increasing the voltage till a discharge is going to be occur. If a rated voltage, above rated voltage, if the discharge is occur, it is okay. And before the standard voltage, rated voltage, if the discharge takes place, then that particular bushing is not tested okay. And power frequency voltage withstand state, this test is conducted for 60 seconds. Momentary is for 30 seconds. Visible discharge test should be conducted in a dark room. Standard voltage is applied. So we will see one by one these tests. First one is the power factor test. As we are having, this is what? A shearing bridge. Here, the two arms which are connected over here, one arm is going to be connected bushing. See here, only one bushing is visible. Second bushing we are not considered over here. So this is the transformer tank on which this bushing is connected. One part of the bushing, one terminal of the bushing is connected to this high voltage source. Second terminal of the bushing is connected to the second arm of the shearing bridge. And this is the variable resistance R3 and variable resistance R4. So this is a shearing bridge, and shearing bridge is used to determine the capacitance. Same determine the capacitance, we are going to determine the power factor and tan delta test. Okay, the procedure is simple. As we are having the vary the resistance, vary the input side voltage, so that bridge is going to be balanced. Okay, now detector will be show. Detector we are connecting, potential difference between them can be determined by using the detector, and we can balance the bridge. So under balance condition, we can find out the value of C2. So we can find out the value of cos C2 or cos phi. And similarly, we can find out the tan delta. So this is the basic procedure by which we can conduct the power factor test. In that, here, if I am going to show you, observation table is like that. You can increase the voltage and decrease the voltage and measure, balance the bridge and measure the power factor angle. That is, we are going to be measure over here. And from that, we are going to be calculate the tan delta test. Here, in the both the test, power factor and tan delta test, if you put in a graphically manner, here tan delta and test voltage, as the voltage is going to be increases, what about the tan delta is going to be increases. This delta angle is called as tan delta, which is very small in nature. If the delta is very small, then and then we can say as a insulation strength is having very good. If delta is very much of high or more angle is there, we can say a particular insulation strength is going to be reduces. This is the meaning of tan delta test. And why we are going to measure the tan delta test? What is the importance of tan delta test? Actually, what is meant by tan delta test? If you want to know, I think you have already covered this in your material science lab. Okay, so I'm going to skip this part. What is the importance of tan delta test? You tell me in the next lecture. Okay, so next topic we are having over here, a partial discharge test. As we are told, this is the construction diagram. This is the testing bushing over here. This is the spare gap 1, spare gap 2. In between them, I'm writing here. There is a quite gap is there. I will write here. This first spare gap. This is the second spare gap. In between them, what is placed? In between them, we are placing the testing bushing. Here, AC supply voltage, cascade transformer, which is used to increase the voltage level. Circuit breaker is used for the protection purpose. Now, if you see this spare gap over here, now what will happen? We are going to increase the voltage. How much voltage we are going to be increased up to the discharge is going to be happen. This cascade transformer produces a very high voltage, which is applied to the bushing. If any discharge takes place due to the voids, due to the crack, then potential difference can be measured. That potential difference should be a standard one. If the potential difference is very less, and due to that, discharge is going to be takes place, that particular bushing you have to be replaced. So that much of standard voltage it should be applied. Okay. So this should be a partial discharge test. Now, okay. Then weight frequency voltage test, we have to apply the voltage up to 60 seconds according to different IS standard, and we have to observe if there is a flash or puncture of bushing is there or not. If there is no puncture, if there is no flash over, then particular bushing is tested okay. Momentary power frequency voltage sensing is for a 30 second we have to apply. Means after certain period of time, after interval of time, you have to apply a certain voltage and you have to check whether that particular bushing should be withstand of that voltage or not. If during that 30 second, is it flash over and puncture is occur, you have to replace that bushing. If there is no puncture, there is no flash over, it can be sustained, it is tested okay. That is called as your power frequency voltage withstand test. Fifth one is a visible discharge test. Visible discharge test means by your naked eyes you can visible whether there is a discharge takes place or not. And this test should be carried out in a dark room. In a dark room, standard voltage is going to be applied. And you see whether there is a discharge or not, visible discharge. If there is a not visible discharge, it is okay. If there is a visible discharge of having the low voltage, then you have to replace with the new bushings. Now, last one is the impulse test. Impulse test means suddenly you have to increase the voltage across the bushing, and you can observe whether the bushing is going to be puncture or not. Sometimes lightning should be there. Okay, because of lightning, suddenly impulse voltage is going to be appear across the bushing. So that impulse test is going to be conducted on a bushing. So this is about the different testings used for the bushing. I hope you understand all the testings. If